There might be a time that we have an exponential expression that's a quotient of two exponential expressions with the same base, but the exponent in the denominator is a bigger exponent than the exponent in the numerator. Let's see what happens in that case. Let's say, for example, we have z to the third over z to the seventh. If we again expand this without exponents and use our simplification rules that we've already learned about, the numerator would be z times z times z, and our denominator would be z times z times z times z times z times z times z. So we have our z to the third, 1, 2, 3 factors of z, over z to the seventh, 1, 2, 3, 4, 5, 6, 7 factors of z. Now, since it's all attached by multiplication in the numerator and the denominator, I can remove the common factor pairs. So here's a common factor pair of z's, here's another common factor pair of z's, and then another pair of common factor of z's from the numerator and the denominator. Now, when I want to rewrite this, I have to show that the extra factors of z that ended up being still within the solution are in the denominator of the fraction. So when we write this, we have our value of 1 in the numerator, and then z to the 1, 2, 3, 4 factors of z that were left in the denominator for our final result. So notice this simplifies as 1 over z to the fourth. Now if we straight just use the rules of exponents, we would have kept the base z and subtracted the exponents. Well, 3 subtract 7 gives me an exponent of negative 4. But we're not wanting to write our final form of a simplification of an exponential expression with negative exponents. They are not as well understood as if we write it in terms of where the base has a positive exponent on it. So what we need to notice from this is that if we have a z to the negative 4 power, that's the same thing as a 1 over a z to the positive 4 power. Negatives on the exponents mean reciprocals. So you have to make sure that you keep that separate from the idea of the negatives that are out in front of the quantities. When we look at having exponential expressions between the numerator and the denominator of a fraction, if it's attached by multiplication in the numerator and the denominator, or if it is the entire numerator or denominator, and your base is to a negative power in one part of the fraction, what you need to do to write the simplification is to move that exponential expression to the other part of the fraction, and when you move it to the other part of the fraction, you change the sign of the exponent. And that's what these two rules are trying to say. So here when I have x to the negative n, remember if I don't see it as a fraction, I can write it as a fraction by putting it over 1. Well, with the negative that's little and up with the exponent, that specific notation means reciprocal. So I want to write it by moving it to the other part of the fraction, and when I move it to the other part of the fraction, I change the sign of the exponent. And this is considered the more simplified form of it, 1 over x to the n. If I have an expression that has an x to the negative exponent, or whatever my base to the negative exponent in the denominator of the fraction, then I want to move it up to the numerator of the fraction, and when I move it to the numerator of the fraction, I change the sign on the exponent. And this is a rule that works no matter what your base is. So let's say, for example, I have a 5 to the negative 2 power. The negative is little and up with the exponent, so it really means reciprocal, so I want